Hello everyone, this is Auditya Gunti. I am chef by profession and intrigued in science. Hence, I consider my kitchen as a laboratory. Today, I would want to calculate the speed of light using my kitchen. Before we go any further, I would want you to understand a little bit about light. Newton has found out that visible light is made up of a spectrum of lights with violet, indigo, blue, green, yellow, orange and red, namely we call it as VIBGR. Even though there is no seventh indigo over here, Newton has incorporated this because he's got a fascination to the number 7. Because in music we have C, D, E, F, G, A and B, and also during those times ancients used to believe that there are 7 planetes. In Greek, planetes means wanderers. If you look into the sky with your naked eye, you would definitely see these 7 objects in the sky, namely Sun, Moon, Mars, Mercury, Venus, Jupiter and Saturn. If you keep observing these every day, you will see the movements as of these planets, so-called planets. They are wandering around us. Hence, they used to call us planets. But today's, due to the science advancement, we understand that Sun is not a planet, Moon is not a planet, because Sun is a star and Moon is a satellite. Do you understand that they have missed the planet Earth that we are living in? Anyways, that's for a different discussion. Let's go much further. Once Newton has found out the visible light is made up of the spectrum, there's another scientist who had measured the temperature of this spectrum. So he has found different readings at different color lights. When he had put a thermometer above this red light, he had found increased temperature. So the temperature used to increase from here to here. And then he found the temperature has gone much higher than the red, above the red. That means it is clear that there is something else that is not visible to us. And then that is how the infrared are found. Accordingly, at different stages of science advancement, we have found out ultraviolet rays, X-rays and gamma rays. I'm sure you all at some stage of your life would have experienced the X-rays, because that is how, if you have fractured a bone or there's any abnormality in your bone structure, you are referred by a doctor to go and have an X-ray, and hence you'll find out. So you can actually see through your body using the X-rays. Ultraviolet rays, I'm sure you all understand and have experienced that ultraviolet rays are used to kill microbes like bacteria. Even in kitchens, we sanitize our knives in an ultraviolet light cabinet. And if at all, if you're living in countries like Australia, you would be much familiar that you would use a sun protection cream SPF plus 50 at least, because of the ultraviolet radiation that comes from the sun damages your skin, and then you develop a cancer. Interestingly, gamma rays kills the cancer cells. So if ultraviolet rays causes the cancer, the gamma rays kills those cancer cells. Is this not something really fascinating? Okay, along this we also have radio waves and microwaves. So radio waves are the waves, those are used in aviation and also in our daily communications through our walkie-talkies. And these are the waves that are used to transmit radios, music or sounds when we were using radios. And still, if you're switching on your FM in your car, that is what we are using to transmit those signals. So microwaves and radio waves are used much in aviation as well. Do you know that your microwave uses this microwave to heat your food? So if we can calculate the speed of microwave, we can understand that the speed of light as well. So going much further. So for today's experiment, we need very simple things that is available in any kitchen. We need a microwave and a chocolate. Who doesn't have a chocolate in the fridge? So pull up some of the chocolate bar and place it on a plate. and take this plate and microwave it in your microwave for 20 seconds. Make sure that you remove the rotatory platform disc under the plate, because we'll get to that in a minute. Okay, once I have done this experiment at home, I've placed my chocolate on a plate and I've put it in my microwave for 20 seconds. Let's see what happens with the results. So I pull it out and I found out at different points the chocolate was melted more than the rest of the place. Have a look. So over there and there I see a soft space, but however the other places remain a little bit more solid. So what have we understood by this? Let's go back. I took out the plate outside and I measured this distance between these two melted spots of the chocolate bar. It is roughly around 6 centimeters. Okay, what has it got to do with the speed of light? Coming there just one second. Before we calculate the speed of light, I would want you to look at your microwave back or some of the details that is there in the manual. I am interested in this 2450 MHz, which is the frequency of the microwaves that's used in this microwave. So, as we understand that today light is both a wave and also a particle. When we speak about the wave has got a wavelength and also a frequency. If you see, that's more of a microwaves where the wavelength is small but the frequency is high. That means the energy is high when the wavelength is small. When you go to the upper part, let's go over there. When you go to the upper part over here, the gamma rays and X-rays have got a higher wavelength, but they've got a lesser energy. Do you also know that microwave oven, the waves in the microwave oven, and also the Wi-Fi at your home works at the same frequency? That is why whenever you switch on your microwave, your Wi-Fi gets disturbed. It might be a doubt to you now that if my microwave waves and the Wi-Fi waves, if both are of the same frequency and if both are the same waves, why am I not get cooked outside the microwave where the Wi-Fi is available, and why my food in microwave gets heated up in the microwave? That's because something to do with something else called as wattage. So if you see, the microwave runs at 1000 watts. However, your home Wi-Fi only runs at 0.5 or 0.7 watts. It is very much less wattage. So you are safe in that way, don't worry. So considering that, now that's a wave of a microwave, of any light, basically, of any wave. So what is wavelength? If you see, when you have a waveform, there are points where the energy is peak. You see those 2 points, the energy is peak, and over here the energy is minimum. If you draw a line here, you would see that there are some points above the line and there are some points below the line, and there are also some points that goes across this line, which means for us to calculate the wavelength, we need to consider the 2 peak points from here to here, and that's considered as one wave. So that's a wavelength. That means from here to here is half length of the wave. That means here to here is half wavelength, here to here is a full wavelength. With this understanding, let's see how does food gets cooked in the microwave. You see, these are the high energy points. The food in the microwave gets heated because the frequency of these microwaves will also make the water pockets in the food vibrate along with them in the same frequency, which means when the water molecules vibrate as well with this frequency, there is a friction generated, and that is how the food is heated. Do you remember I said that to remove your rotatory platform? Yes, that's because if you see these white dots, that's the area where the strength of the microwaves are weak. Hence, you find whenever you cook a food without a rotatory disc, you will see the food has got a cold areas and also extreme hot areas. That is the reason. The extreme hot areas are the areas where the waves are hit with this high energy, and the cold parts are the parts where the energy of the microwave is less. The frequency is less. Okay. With that understanding, when we take out the rotatory platform, we don't have the uniform heating throughout. Hence, the chocolate gets melted only at these points. Do you understand? So if you go back to our chocolate, which is melted, so these are the points where the energy was high in the wavelength. So if you go around this chocolate, you would find at every 6 centimeters difference, roughly, you will find there are softer spots than the rest of the areas. So by this we understand that we have measured this distance between here, the high energy point here, till here as 6 centimeters. But that is only a half the wavelength. As per here, we only found here as 6 centimeters when we calculated. From here to here is only 6. For us to have the full wavelength, we need to multiply that by 2, which is 12. So we have one wavelength that we found out as 12 centimeters. Let us put this into formulation now. For us to understand a speed of wave, there is a relationship between the speed and the frequency of a wave. If v is wave speed, then lambda f is the relation of the wave speed. So lambda is the wavelength and f is the frequency. So for us to find out this wave speed now, the speed of light, we have the wavelength that we just found out and the frequency. Do you remember how much was it that I showed you on the microwave? Exactly, 2450 megahertz. Okay, let's calculate the speed of light now, which is the wavelength into frequency. As we found out that the half wavelength is 6 centimeters, now our full wavelength is 12 centimeters. So let us put these values into the formula. So the speed of light v is equal to the wavelength, which is 6 multiplied by 2, because we only counted the half wavelength where the energy points were the high, and then multiplied by 2450 megahertz, which we found out through the microwave details. If 1 megahertz is 1 million cycles per second, then 2450 megahertz would be, we need to do this conversion because we are calculating the wavelength here in centimeters and we can't have the frequency in megahertz. So for us to find out 2450 megahertz into hertz, you need to multiply that by 1 million. So we get 2.45 billion cycles per second, which is the speed of light is equals to 12 centimeters multiplied by 2,450,000,000 cycles per second. When you calculate that, you will get this number, which is 29,400,000,000 centimeters per second. So that's the total experiment that we did. We counted the half wavelength and then we multiplied by 2 so that we got a full wavelength of 12 centimeters, and then we converted the megahertz into hertz, and then we multiplied the wavelength by the frequency. So we've got this in centimeters before earlier here. Let's convert that into a meters per second. So it is this number. It is 294 millions meter per second is the speed of the microwave that we found out through the experiment. But hold on, actually the speed of light in vacuum is this much. We've got a variancy. Why is that? Because that's the speed of light in vacuum, and our microwave is not a vacuum, there is air in it. Also, we have done this experiment in an uncontrolled environment. We have not double checked the IKEA measuring tape that we used is perfect or not, and then we did using a simple chocolate. So I'm still happy, even though the variance is in millions. That's very negligible when you do this kind of experiment in a kitchen. So we found that the speed of light is 2.9 multiplied by 10 to the power of 7 meters per second. I'm pretty happy that using a bar of chocolate and your home microwave, you could find out the speed of light. Beautiful, isn't it not amazing? So that's the end of today's experiment and discussion. Hold on, it is not actually, because this experiment is actually a great experiment, because it is the only experiment that where you can eat your results. Is it not something really great? While you enjoy your chocolate, I will get ready for the next video. Thank you very much for watching. See you next time soon. Bye.